So hello everybody, I'm Stefano Cresci, I'm a computer engineer from IIT Siena, the Italian National Research Council, and I'm going to talk about malicious accounts and automation in social media. Malicious accounts are of course accounts created for shady and illicit purposes. They are often automated, not always, and they are deceitful, of course, because they want to hide their identity. They want to look like natural, organic accounts. I won't spend much time on this because we all know why those are important. They've been polluting our social environments, and they're doing it now more than ever before. Many of these accounts, many of those threats actually do not peculiarly belong to social media, but they come from other socio-technical systems like file sharing systems, where civils try to increase the popularity of malicious files like viruses and also spam, for example. We already know that there was web spam trying to cheat web search engines. There was email spam. So those are not peculiar to social media, but social media nowadays represent a very fertile ground for the spread and proliferation of these accounts. Mostly because social media are open platforms. They allow for a great deal of anonymity, and also they have means for automatic and programmatic access. So people can automatically get content from social media, but also post content on social media, and also establish social relationships. So all these things actually make social media very vulnerable to these kinds of attacks. And there are very different kinds of malicious accounts. I'm going to focus on some of these, those kinds that I think are more widespread today, starting from fakes and civils. So civils are referred to many multiple identities that are created within a social ecosystem with the purpose of increasing the popularity of something, increasing the popularity of public characters, for example. And again, civils have been used in the Tor network, in file sharing systems, and the same techniques that have been used in those decentralized systems are now used in social media. One kind of civils that is particularly widespread today are fake followers. Fake followers are like empty shells, bare profiles that have been created just to inflate the popularity of other characters, of other social media accounts. And because they just need to increase the popularity of somebody else, because they just have to follow somebody else, they typically are very passive. And this is what fake followers looked like, at least a couple of years ago. Nowadays the situation might be worse, but as you can see, those were just empty profiles. They don't have a profile pic, they don't have personal information, they don't tweet, they don't need to, because they just need to follow somebody else. And so they don't have followers, but they do follow quite a few other accounts. And you might have seen this visualization right here. This was the result of a study from the New York Times. It has been published very recently, some weeks ago, I think. And this is the overview of the accounts, of the followers of one account. And as we can see, there are some distinctive patterns. They have been marked in red, of course. When the account was created, his followers have a rather spread creation date, a rather spread join date to the platforms, and so no patterns is present in the followers. But all of a sudden, we can see that thousands of followers almost simultaneously follow this account, and the creation date of all these followers is very concentrated in certain periods of time. And this means that all these accounts were created simultaneously, and that simultaneously followed the target account. So this is what fake followers look like. So let's pass to another kind of accounts, the spammers. Again, spam is not peculiar to social media, but it is more dangerous in social media than, for example, in emails. This is because these social media accounts can become very credible, and so people are lured into clicking the malicious links, for example. And spammers are basically the opposite of what we saw before, because they have to be very active. They want to create a lot of content, so they produce content and they are very active in the social platforms. And this, of course, has many implications on the techniques that we want to design to detect them. Because techniques targeting fake followers will be obviously much different from those targeted to detect very active accounts, such as spammers. We have bots, and by bots we refer to automated accounts, so accounts that are not driven by a real person, but they are driven by a software. Not all bots are bad, but bots are being used very much in conjunction with spammer accounts, because spam accounts need to post a lot of content, they need to spam, and so they use a software to do so. This is what spammers might look like with a spam bots, let's say. They post a lot of messages, which typically look all the same, one to the other, and also these can be organized into botnets, meaning that there might be hundreds or thousands of these accounts that follow each other, and they might look something like this. Okay. So we said that there are a lot of different types of malicious accounts, and because of this, there are also a lot of different types of detection techniques, each one aimed at exploiting some of the characteristics of those malicious accounts. The vast majority of detection techniques for these accounts are based on machine learning. And typically they're based on off-the-shelf and general-purpose algorithm, meaning that I take, for example, a decision tree algorithm, which can be used for a lot of different purposes. I just focus on features, on the characteristics of the account that I want to detect, and I apply the decision tree algorithm to perform a classification. This is what basically the vast majority of papers being published now are doing. They are following this approach. There are a few notable exceptions to this, and I will cover them a bit later. And basically, as I said, the focus is on account characteristics. So which features of the account I can exploit in order to discriminate the malicious accounts from a real, legitimate one. So of course I can take into account characteristics of the profile. As we said before, fake followers are empty shells. So I can look if an account has a profile picture, if it has many friends, if it posts a lot of content, if it has a description, a URL to a personal page, all this kind of stuff. Or I can also look at the content of the messages that are shared. Obviously, techniques based on the content of messages would not work for fake followers because they don't produce content, but they might work very well for spammers, because spammers repeatedly post the same kind of content, basically. So by analyzing the content of those messages, I could understand that a group of accounts are actually a group of spam bots. Or then I can also focus on social links. As we saw before, some kinds of accounts tend to all follow each other, and this, of course, creates peculiar network patterns. So if we study the network of the connections between the accounts, we can maybe understand that a certain group of accounts are connected in a suspicious way, and so perform the detection. And all these three kinds of analysis that I introduced now are, let's say, static analysis, meaning that I take a snapshot of an account or of a network of accounts, and I perform the detection on that snapshot, that of course is related to one specific moment in time. But I can also perform some dynamic analysis, for example, analyzing the behavior of an account over time. And so I might understand, again, for spammers, let's say, that a certain account continuously posts content over 24 hours, meaning that it never stops. So it never goes to sleep, let's say, okay? And I might understand that something strange happens regarding to that account. Or also, we talked before, somebody talked before about cyborgs. There are cyborgs, there are compromised accounts, which are accounts that have been taken over by malicious users and used to spread spam or malware or whatever. And also, if I analyze the behavior of those accounts, I might see a shift, a switching behavior when they get taken over. So this behavioral analysis might be useful in those situations. Then, of course, there are combinations of all these kinds of analysis and crowdsourcing, where I basically ask a large amount of human workers to manually label the accounts. And this has a number of drawbacks, like that human workers must be paid for the task. Human workers get tired. And also they need to be expert of what they're doing, otherwise they are not efficient in the detection. Okay, so given all these nice detection techniques, did we actually solve the problem? Well, we did not at all. We did not, and mainly we failed because of malicious accounts evolutions. Because as soon as a detection technique has been developed and it has been put in place, the developers of the malicious accounts tweak the behavior of their bots, let's say, and as a result, newer accounts are much more sophisticated than older ones, and it gets always harder to detect them. So, what happened recently? Okay, part of it is cut, but it's okay. What happened recently is that a new group, a new evolution of bots came out. These are called the social bots or social spam bots. These accounts are, again, are organized in groups. They perform coordinated and synchronized actions. Their profile is very detailed. They have profile pictures, which are stolen from other accounts. They have fake descriptions. They have links to purportedly personal websites. They have many followers and friends, and those followers and friends are real people. Since they represent credible accounts, real people follow them, so they don't have that peculiar network structure that we talked about before. And so, if we analyze those accounts one by one, they are actually indistinguishable from legitimate users, which makes it very difficult for us to perform the detection. So this is an example based on Italian accounts. Then I have another one for, English-speaking accounts. One of those is a bot, and the other one is not. And as you can see, they all have a lot of tweets. They follow a lot of people. They have a description. People I know are following them. Okay, so some people that I know on Twitter is actually following a bot. They post media, so videos and images, but one is real and the other is not. And this is what you are confronted with when you jump into the platform and you look at an account. So it's very difficult. Okay, and so we performed an experiment, crowdsourcing experiment, where we basically created a data set with roughly 1/3 of genuine accounts, legitimate accounts, 1/3 of old traditional bots, the non-evolved ones, and then 1/3 of social bots, the ones that we just saw. And we asked different Twitter users whether the accounts that they were seeing was a bot or a legitimate accounts. And these are the results. So, as we could expect, all bots are correctly recognized in 91% of the cases. The same basically applies for real accounts. While instead, the evolved bots, 3 out of 4 of the evolved bots are not recognized as such. They are misdetected as legitimate accounts, as real users, which is rather bad. Since every account has been labeled by at least 3 different human workers, we could also compute agreement metrics. So when the workers labeled the different kinds of accounts, did they agree on the class or not? And it turns out that we measured the moderate agreement for the real accounts. So remember, 92% accuracy. So majority voting actually allowed them to correctly label the accounts overall. And they also moderately agreed on the label. While instead we measured a low agreement for social bots and a very, very low agreement for all bots. And this means that the human workers were, they agreed more when they wrongly labeled social bots as humans than when they correctly labeled the old bots as bots. So this was rather surprising to us. Another thing that we looked into was the Twitter's capacity, social platforms' capacity of removing the bad accounts. And again, we performed this comparison for the old style bots and the new ones. And it turns out that 60% of the old bots get removed after a certain amount of time. We might have expected more. I mean, those are accounts that have been studied in academia a lot of years ago. So detection techniques, state-of-the-art detection techniques for these kinds of accounts reach up to 90–95% of accuracy in the detection, but only 60% of them are actually removed from Twitter. And for the social bots, the situation is, of course, much worse. Only 4% are removed after years of activity. Okay. We also tested a few state-of-the-art detection techniques. These techniques all achieved very good results on the old generation of bots, but they do better, of course, than Twitter, but they do not reach completely satisfactory results. And these techniques are all different kinds of techniques. I mean, they are based on different machine learning algorithms, but yet they do not achieve satisfactory detection results. So this strengthens the point that these new kinds of accounts are almost undetectable if analyzed one by one, which is what all these techniques were doing. But rather, we need to start looking at these accounts as a whole, as a group, and see if we can detect them. And a literature review in this field actually reveals that since 2013, a few research teams independently started to develop new approaches to this problem. And in these new approaches, they were not looking at one account one by one, but they were actually considering large groups with the aim of detecting possible traces of automation within the group of accounts. And another interesting thing of this stream of research is that researchers also started to develop ad hoc detection techniques. So no more general purpose machine learning algorithms, but detection techniques that are specifically targeted for malicious account detection, which of course boosted the results. So of course the basic idea is that even if single accounts might be almost undistinguishable, a coordinated group of accounts that has the same goal is more probable to leave traces of automation behind, which is what we want to exploit. And I just want to show you a couple of things, a couple of these techniques, a couple of examples. This is a technique that I developed together with a few colleagues from Italy. Basically, we choose a set of actions that we want to monitor on the social platform. These are very basic actions on Twitter. To each of the actions that we want to monitor, we assign a distinct character. And then by scanning the list of actions performed by an account, we assign to each of the actions the corresponding character. Okay? We scan it in chronological order. And we end up with a string of characters, of course, and we call this thing like the digital DNA sequence of that account. Okay? So this string actually encodes the behavior of that account over the course of time. And this is about modeling one single account. But then, as we said, we want to analyze groups. So we need some means to compare these digital DNA sequences. And again, we want to measure the degree of similarity between different accounts. And what we do so is to look for repetitions in the digital DNA sequences of different accounts, so repetitions across different accounts. We do so simply by measuring the longest common substring that is common to all of those accounts, which in this toy example here is this string right here, whose length is 7 characters. And the conclusion of all of this is that if we perform this analysis for a large group of accounts that contains both legitimate users and spam bots, the evolved spam bots, we can see that the similarity curve between the accounts shows 3 distinctive parts. One part in which there's a large group of accounts that shares a high similarity. Then there is a steep decrease in similarity, and there's another group of accounts where those accounts actually have almost no similarity at all, so their behaviors are very heterogeneous. And as you might expect now, the accounts that share the high similarity are actually the bots, while these accounts right here are the real users that are very heterogeneous. Of course, the trick in this is similar to feature engineering in machine learning. You have to pick the right encoding, because if you don't do that, of course, this technique doesn't work. This one achieved 95% detection accuracy for the new kinds of bots. But there are a few other examples. I choose this one. There could have been others. This one is rather simple. So basically here the idea is to compute the statistical distribution of something that is called the reputation score. It might be the join date of a group of accounts into the platform. We saw before the join date is important. Patterns can be seen in the join date, also because you can create a lot of fake information regarding an account, but you cannot forge the join date. That is something that you cannot manipulate. So join date is important, but you can also do the same for the statistical distribution of the number of followers of a group of accounts, the number of statuses produced. I mean, you can choose whatever you want, basically. And if you compute this distribution for a group of legitimate accounts, you end up with something like these red lines right here, where basically what this tells us is that the distribution of those values span all the possible values, basically. Okay, so it's a very spread distribution. While if you compute the same thing for a group of accounts that contains social bots, since some of these things are hardly, they can be hardly manipulated, you can see that something strange happens, like that the join dates all correspond to a single time, or they show a very odd behavior. And by computing the distance between these statistical distributions, you can detect whether a large group of accounts has some social bots inside. Although this technique doesn't tell you which are the social bots. It just tells you that in a large group of accounts, there is something wrong going on, okay? But this is very simple. It can be implemented very easily. It is very efficient, so it's a good example of how group analysis can actually help solving this problem. So I just have a few more slides. I wanted to wrap up things. We saw that the problems with social bots is a real and tangible problem nowadays. As much as 60% of the old bots are removed. The others are still present and doing their job in our social ecosystems. And this issue is actually bound to worsen since the emergence of this new this new kind of social bots, which are much more sophisticated, so much more dangerous. Only 4% of them are removed from social platforms, Only 24% of them are detected by humans when they manually look at the accounts. And state-of-the-art detection techniques, most of them are currently not capable of efficiently spotting these social bots. So I think as people interested in working on the detection of these accounts should focus on developing new analytical techniques for this problem. And I mean, we have a few ideas on how to get better. For example, by developing ad hoc detection algorithms, by focusing on group analysis. And there was supposed to be one last row there that was saying that we should start taking care of proactive detection, meaning that we know that account evolutions are actually creating problems to our detection techniques, but can we try to anticipate the next evolution of bots? Why do we always have to react after they have performed something bad? So something that we should look into is the possibility to foresee, to anticipate, maybe with simulations, what the next evolution could be, and try to anticipate the evolution and develop detection techniques that could work also for the evolved accounts. I want to list 3 other challenges that we're facing right now. The first challenge is that the detection of malicious accounts is a topic that actually receives attention from at least 3 different scientific communities, which is the scientific community about web and social media, the one about security, computer and information security, and the one about machine learning, data science, data mining, the analytics community. But anyway, being here today actually let me understand that many more scientific communities are actually interested in this kind of stuff, even if they're not developing the tools themselves. So the result of this is that there are really many papers published every week in many different conferences and journals about this topic, and we do not have now a comprehensive survey that organizes all these papers. This is getting very difficult to follow the new updates and to spot the new valuable paper out in the deluge of paper about these topics. So we need a survey. Similarly, we also need reference data sets. And that is a very difficult job because, as I said, malicious accounts evolve quite rapidly, so it's not easy to collect a data set. Typically, those data sets need to be manually labeled, which is a time-consuming and error-prone process. And you have to keep the data sets updated and then track the evolutions. And there are many different kinds of malicious accounts. So all these things are a problem. But we need reference data sets because otherwise we cannot reliably compare different detection algorithms, which is a problem. So there have been a few efforts, also from some of the people that are right here, to create repositories for data sets. We need to make them more visible and to increase the number of data sets available and start using them. The last thing that I wanted to say is that I'm a social media analyst, so I come in between from the web analysis and the data mining field, and I need data to do my job. But what has recently happened is that as soon as malicious social media accounts are identified by social platform administrators, they get removed straight away. And it's difficult to get access to the data of those accounts because as soon as they are removed, the data is not available anymore. I don't have data grants from Twitter or this kind of stuff, so I don't have the data often. And this is a problem because a lot of people would benefit from having access to data about removed accounts. We could perform a posteriori analysis. This is very important. And so we should do something about this. Maybe get some data grants or change the way those accounts are removed. Thank you. I'd be happy to take any questions.
malicious social accounts, and specifically thinking, are you arguing that spam bots, which are largely involved in unwanted advertising, are later going to be involved in harassment or disinformation campaigns or some other actual malicious activity? Is that the, could you draw those connections?
Yeah, that connection is true. I mean, not all social bots do that, but a few are actually doing it. Groups of social bots have been witnessed injecting fake news in social media ecosystems, or also massively retweeting accounts of politicians, the tweets made by politicians. So they are interfering with political topics, also with brands.
So ones that look like the spam bots that you're showing.
Thanks for your talk. I really like the basically bot DNA approach. I thought that was pretty cool. Two questions. One like more from the method side, and one like more with regards to impact. Because I've done some research on like how bots are being talked about, and like basically the one finding that struck me there was that bots in itself has become like politicized / weaponized. So bots in themselves are like just the fact that they exist kind of like is problematic for online debates and discourse, because basically it's always like possibility of like saying you're a bot or these are bots. So what is like, what are you assume is like the real like impact of bots like that goes beyond the noise that we see on like our analysis? And the second one, you have like this slide basically where you have like human coders kind of like saying this is a real bot like account or this is a bot account. And I was wondering like how much time per like basically judgment these human coders have, and like basically if you could expand on that. Thank you.
Okay, so I'll start from the second question. They had all the time that they wanted. We provided a link to the real Twitter account, and we delivered them instructions, detailed instructions on how to perform the task. We had test or goal questions to check whether they were actually doing their job or not. We didn't actually quantify how much time they spent on the account. We did check that they accessed the account. But of course, there are always some concerns regarding crowdsourcing, because the workers, I mean, their point of view is just that they want to complete the task as fast as possible to get the reward.
So it was like
yeah, it was Crowdflower, but basically, I mean, it's the same. Anyway, the goal questions were about the legitimate accounts and about the old traditional bots. And we wanted that at least 70% of those test questions was passed correctly. So, I mean, that mechanism kind of safeguards us from people randomly clicking and going through the job, okay? So regarding the first question, it was about the impact of social bots. Okay, so I'm not stating that all bots are bad. Actually, there are many bots that have a neutral or a beneficial impact. I'm also studying, for example, social media emergency management, and there are a lot of bots that try to help in the aftermath of an emergency, organizing the information or spreading news of the emergency. But anyway, the big problem, I think, is about coordinated and synchronized large group of bots, because those kinds of accounts can actually have an impact and create serious consequences. There have been elections in Italy yesterday. We were monitoring, of course, the social media discussions about that. We found a few bots, but actually those that we discovered were not colluding together. They were like lone wolves, okay? Each one behaving on its own. And even if some of those created a lot of content, the visibility that content can have is rather limited. So I think that the real threat now is represented by large groups that act in a coordinated way.
Thank you for your talk. Two questions. The first one is about reference data sets. You point out how difficult it is to know what a bot is or not. So what did you use and how did you have faith in your actual reference set itself? The second question is about the future of detection. So if the detection techniques that you have, which look really great, the DNA thing, is based on pattern recognition, like presumably anything that relies on pattern recognition, even as it gets more sophisticated, there are countermeasures by bots that could put stochastic elements into any of that. So is it ultimately a losing game trying to identify bots?
Okay, this is a very difficult question.
I'm sorry.
But it's a very interesting one nonetheless. So the reference data set, I'll tackle the easier one first. All the data sets that I know of have been manually labeled. And this is what we all also did. What we did in order to be reasonably confident about our labeling of the data set is not to label each account by its own, but we developed a tool that helped us compare the behavior of different accounts, okay? So when labeling one single account, we were actually comparing it to many, many others. We knew that for that specific data set it would work because we witnessed to what those accounts were doing. Those were social bots employed by Italian politicians in an electoral campaign, not this one, the previous one. And so we developed a tool that could help us spot whether those accounts are performing a coordinated action. I think it worked, but anyway, I cannot be 100% sure by myself. What we did is to publicly release the dataset so that other researchers could download and experiment with it, and that, I mean, over the course of time would surely allow to understand whether the dataset is a good one or whether it has some drawbacks or some limitations. But as I said before, one way to be more sure when labeling could be not to look at single accounts, but just to compare them, okay? That would safeguard from some mistakes. Another thing could be, as I said before, if lists of suspended accounts from social platforms could come out, then we could have access to that data. Then that would serve as, let's say, as a labeling, okay? As an implicit labeling of those accounts. Also, there have been anonymous that created lists of ISIS-operated accounts or something like that. I don't know how they did it. They might have more information to exploit than us, because as I said, I only have access now to what Twitter actually makes it available, and the same applies for Facebook and Instagram and so on, which, by the way, give much less information than what Twitter does. Twitter, of course, might have IP addresses and a lot of other stuff to access logs and so on and so forth. So that could be one favorable way of creating labeled data sets. Okay, so the future of detection algorithms. Of course, as I said in the title of my presentation, I said detecting social media accounts, the never-ending clash. So I don't think that any of the techniques that have been proposed so far can be the ultimate detection technique and solve the problem. No. What I think would be useful is just to start raising the bar for account developers and make it so that they need more time and more effort to create credible, plausible accounts. If you're able to spot their accounts and ban them and make them spend a few months for creating new ones, then we might turn the tide, okay? So that is something. Mm. And the other thing I think I would look into is the proactive detection, because as you said, changing the behavior basically tricks every detection technique that is based on a pattern, and so trying to anticipate, trying to foresee what could be the countermeasures taken by the account developers might also put us one step ahead, which is, I mean, the contrary of what it is now. We've always been one step behind, actually.
One last quick question, is that okay? It's on the same topic of the detection of social bots. I was wondering because one of the things that seems to distinguish these social bots is first that they might use identity theft and use pictures taken from other from other people and some of the information taken from other people. Isn't there a way of using that actually to our advantage and using the metadata, for example, within those pictures to match them up? If they're taken off Google, of course, that would be easy to find out, but also if there's a common pattern across different accounts taking fake identities from the same source, basically. Is that something that metadata?
Yeah, that's an interesting point. Yes, so the fact that they are actually stealing some information from other accounts make the single accounts more credible, of course, because this information is taken from a real one, but also exposes them to being detected in that way. And when they actually just copy the image as it is, or just copy a description or the content of a tweet, then it could be possible to spot them based on this. Anyway, some of those developers actually try to modify the content of the content that they steal from other accounts. So for instance, the profile picture gets color shifted, cropped, and they perform some kind of visual alterations on the image, so that from an algorithmic point of view, I mean, they're obviously not the same image anymore, and I'm not sure whether visual analysis outrun could be able to actually detect that it nonetheless refers to the same person. I mean, it was the same image, okay? I don't know whether this would work or not. I've never seen it tested. Another point that I would like to focus on is that, okay, here. If you analyze one single group of social bots, when you see them, you of course recognize some patterns. Those patterns might be also easily spotted. For example, some developers of accounts use the same pattern for the screen names of the accounts. Okay, like the camel style for capitalization and then a series of numbers at the end. Okay, it's very frequent. But not all of the developers use that same patterns. So, if you have one group in mind, it is very easy. But I mean, after you see, it is very easy. But what we should do is to to develop a general enough solution that is able to spot these patterns, but I mean, a very large number of these patterns, okay? So that's why, for example, in this experiment, we picked a very generic encoding. We did not want to focus on, for example, tweeting a URL of a specific domain, which you can do, or tweeting with a specific keyword. We wanted to be as generic as possible, so that many different types of accounts could nonetheless be profitably encoded. I don't know if I managed to explain.
Sorry, one more question about detection. Is it possible if there's, for example, probably some of the bots are trained to read every single tweet that a person, a politician, say a politician puts out, right? Read every single tweet that contains a certain keyword and hashtag. Is it possible to, in other words, that already being done?
Yeah. Yeah, it's possible to do that. Those that I analyzed personally, they were not retweeting everything. They were retweeting something, because those were, I mean, at least to a certain degree human operated. I mean, there was, I think, some human intervention that was manually saying what to retweet and what to, I mean, ignore. I've also seen other kinds of social bots copying tweets posted by other people randomly and interweaving their malicious activity with many other seemingly genuine tweets. So it can be very difficult, and also it's very diverse, and that's why also detection techniques should be as generic as possible, although still being, of course, very efficient. Thank you.